Hi guys, in this video we're going to be looking at piecewise functions. A piecewise function is exactly what it sounds like. It's a function that is presented to you in two or more pieces. You've got, instead of just one equation, you've got f of x equals x plus 1 as well as f of x equals x squared. Now, this part is your function, and this part is your domain. These are the x's that are allowed to go into this piece of the function. So from -3 to 0, including the -3 but not the 0, can go into this piece of the function. And 0 to 2, including both 0 and 2, can go into this piece of the function. So if we wanted to evaluate, let me come over here and evaluate. If we wanted to evaluate f of -3, we would take the -3, because it's in this piece of the domain, and put it into the x plus 1. So -3 plus 1. And that would tell us that f of -3 is equal to -2. Okay? If we wanted to put in a number in between here, let's say we want to put in -1, so let's find f of -1. We're going to take the -1 and put it into this piece of the function, because the -1 is between -3 and 0. So -1 plus 1, so f of -1 is going to give me 0. And then if I put the 0 in, I would not put the 0 into this piece of the function because we're not going to include it there. I would put the 0 into this piece of the function because it is included here. So we would say 0 squared, so f of 0 is equal to 0. If I wanted to evaluate f of 2, 2 is in this domain, so I would put 2 into the bottom piece of the function. So 2 squared, so f of 2 is equal to 4. So this is how we evaluate a piecewise function. Now the next thing we want to do is graph this piecewise function. So I'm going to try to color code the graph so that you can see what's going on. First of all, we are going to make tables. So I have two pieces of the function that I have to graph. So I'm going to graph first the f of x equals x plus 1. And then second, I'm going to graph f of x equals x squared. In order to do that, I'm going to make tables. Okay? The x's and the y's. All right. So the first thing that you do is you always graph your boundary points. For x plus 1, -3 is the lower boundary, so I'm always going to put -3 on the graph. 0 is the upper boundary, so I'm always going to put 0 on the graph. This function is a linear function. F of x equals x plus 1 is a line. So I really only need 2 points. So for a line, you can do the lower boundary and the upper boundary. Now we're going to evaluate just like we did over here. So I'm going to put into this function the -3. Well, we've already done that over here. So we know that f of -3 is equal to -2. Now when we evaluated 0 over here, we put it into the second function because that's where it's equal to. But when you're graphing, you have to find out if this was included, what would be the boundary. Okay, so put in 0 here. So I'm going to find f of 0. That's 0 plus 1. So f of 0 is equal to 1. Because I need to know where this graph stops. So this is the boundary point, and because it has an equal, I include it. So this circle is closed. This is the other boundary point. There is no equal under it, so this one doesn't get included in my graph, so this point is open. Okay? So now I'm going to come down here and I'm going to actually graph this part of the function. So let's see if I can do this quickly and neatly. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. And 1, 2, 3, 4, 5. That should be enough. Okay, so here's my, I'm going to scoot up just a touch. Here is my coordinate plane. So let's graph these 2 points. -3, -2. That's a closed point. I know that because this has the equal sign under it. And 0, 1, okay, 0, 1 is an open point. Let me see if I can make that open. 0, 1 is an open point. So let me connect those now. And that's the first piece of my graph. Now we're going to do the second piece of the graph. The second piece of the graph is the x squared. So I'm going to make a table, again, for x squared. Here's the x, here's the y. Again, I'm going to just put in my boundary points. I've already plugged in 0 here, so I'm going to plug in 0. And when I plugged in 0 to the bottom piece, I got 0. I'm going to plug, and let's see, let's talk about open or closed first. This is closed because it has the equal sign under it. Now I need, this is a parabola. We should know that this is a parabola because it's a squared function. So I need more than 2 points. So I'm going to plug in all of the integers between 0 and 2. So 0, 1, and 2. And let's see what it looks like. Okay, I'm going to plug in 1 over here. So I need to come over here. I'm just going to do it on this side. I'm going to do f of 1 because I don't have that one over here already. So I'm going to plug in 1 and square it. So f of 1 is 1. And I've already plugged in f of 2. I know f of 2 is 4. So I have 0, 0, which is this point right here. It's closed. 1, 1, which is this point right here. And then 2, 4 is also closed because it has the equal sign under it. So 2, 1, 2, 3, 4 is also closed. Now this is a parabola, so it's not a straight line, it's a curve. Okay, and it stops right there. And that's a little messy. I apologize that it's a little bit messy, but I hope that you can see what we did there to graph the piecewise function. So in this video, we've evaluated piecewise functions and we've graphed a piecewise function.